This is a computer. This is a person.
Hello?
So, let me ask you a question. What is more biased? A computer or a human? Well, to answer that, first we need to understand what image recognition actually is. Image recognition is exactly what it sounds like. It refers to the process where a computer can actually understand what's inside an image. So this is what a normal computer sees. A bunch of numbers. These numbers represent the amount of red, green, and blue light inside a pixel, with 0 being the least intensity and 255 being the highest intensity. So for example, red would be 255, 0, 0. But even though we know what colors these are, we still don't actually know what's inside the image. That's why with image recognition, we can go from this to that. Why lavender Crocs? Well, most people use cats when explaining image recognition, and I want to do something different, so lavender Crocs. The process that the computer uses to go from here to here is something called convolutional neural networks, or CNNs for short. CNNs are a type of neural network, which is a bunch of different algorithms functioning together in order to achieve a certain goal, much like the neurons in your brain. They're made up of an input, a bunch of different hidden layers in the middle, which is where all the math happens, and an output. So in this case, the input would be a picture of lavender Crocs, or specifically the RGB values inside it. It would separate this picture into a bunch of smaller sections to make it more manageable for the calculations. After that, it will go into the hidden layers. The hidden layers is where convolutions happen, or mathematical operations. So this gets pretty complicated because there's a lot of matrix multiplication involved, and I don't want to get too into it. All you need to know is that the computer is trying to piece together a puzzle. So first, it'll start off trying to find something simple, like an edge. An edge is just a lighter and a darker side. So it's pretty manageable for the computer. After that, it'll put these edges together and build, let's say, a curve. And then it'll put these curves together, and now it can see maybe the bottom of the shoe in that arch. And eventually be able to see the holes in the Crocs, or maybe that strap. And it'll finally understand that, hey, it's a lavender Croc. Along the way, there's something that happens called max pooling. Max pooling is another way for the network to break the image down into more manageable sizes for the convolution. So it'll split each image into different sections again, like earlier, and just choose the highest number from each section to use it for the convolution. So the output is a bunch of numbers that represent the probability of the image being a certain class. Let's say in this case, the neural network has two different classes, lavender Crocs or socks with sandals. Now the highest number would be for the lavender Crocs class, and thus classify it as such. So now we have a network that can actually recognize what lavender Crocs are. Yay! What you would use that for, I don't know. But there's a problem. This network can only recognize lavender Crocs that look exactly like the training image. But real life isn't like that. Maybe the pictures have different lighting, maybe they're at different angles, or there's an object in the way, like a shoe tag. So what now? The algorithm will see this and be like, I don't know what to do with this. This is why it's important to have a diverse set of data, so the network knows what to do with all these different types of images. But that's only with Crocs. What if you get to people? This is where bias starts getting into play. So 2 years ago, a scientist from MIT Media Lab named Joy Bulamwini did a study called Gender Shades. She wanted to see how accurate these face recognition algorithms were in identifying people across different genders and different skin colors. So she tested 3 algorithms, Microsoft's, IBM's, and Face++, and found that when trying to recognize lighter males, they all had about a 99% accuracy. Yet when they were trying to identify darker females, the accuracy went as low as a 65%. That's about a 34% gap. So they've claimed that they have improved their algorithm since then, but it still shows that there's a bias at play. But why is this happening? Well, Patrick Roeder, a scientist from the National Institute of Standard Technology, said that it might be because photographic technology is just inherently takes better quality photos of lighter skinned people. He also made the claim that darker skinned people just looked more statistically alike. All very controversial arguments, but I think it's more simpler than that. For one, it's because there is a lack of diversity in the dataset. And Joy agrees with this. She says that most of these face recognition algorithms get their datasets from the web, which is just skewed towards white Western men. There is also research found that of the 3 most widely used face recognition datasets, they were composed of 81% lighter people. So clearly, there's something biased in the datasets. But I believe it's also because there's a lack of diversity in the workplace. Just think about it. Joy did this study 2 years ago, and she only did it because as a darker female herself, when she was trying to build and train her own neural networks, she found that they wouldn't recognize her face unless she wore a white mask. So clearly there's something wrong there. And these face recognition technologies have been around way before 2018. So this problem has been around for many years, and only recently have scientists begun to realize that it is a problem. So what can you do? One of the most simplest things is to just ask yourself, are my solutions being inclusive of people? Because as we're relying more and more on AI for things like identification or tracking down criminals, it's important that there is no bias. So let's go back to my original question. What is more biased, a computer or a person? I mean, at least even a person can see darker females as people. So I guess that's for you to decide. But I hope that one day we'll be able to get back to a place where computers are more neutral than humans. Thanks for watching, and I'll see you later. And what, so she said,
Go, you've recorded 12 minutes.
the lowest.
How many got the clip?
What?
Just go.
Okay. Highest was only a 74. Found that the lowest. Okay, I'm almost there. I'm so close.
This is your last take, like only take, because you took so long.
I'm so close.